Hey guys, welcome to AlgoYogi and let's solve path sum. Let's go to the LeetCode. Given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values in this path, from root to leaf, that equals to our target sum. Then you return true, otherwise you return false. So fairly easy problem because we have already learned how to traverse a binary tree, and we don't have to go back always on iPad to just show up all these how we're gonna approach the problem. Just maybe let's try to imagine how we will be processing the solution. Traversing our tree, and once we reach any of the leaf node, that means we have reached a path, we have covered the entire values till that path, and that's when we make that condition check if it is equal to target sum. If it is, then we return true, otherwise we return false. And when we are using recursion, we have to traverse the entire tree, unless we just actually, I don't know. I think we have to traverse the entire tree. So in that case, if we are using a recursive function, we will have to keep flag, basically has path sum flag. Okay, not has path sum, has target sum, which will be false. Oh my god, what am I writing? False. And then we will have this helper function, basically, let's just call it path sum, that will have the root and also current value, well, just call it well. And now we're going to have a condition: if our root dot left is none and root dot right is none, that means we are on the leaf node, and being on leaf node is where we check the condition. If so far we have collected all those values in our current value, right, that will sum up all the values. So initially we will be calling this function, and let's just write the function and then call it. So we will be basically checking here, let's just, if our target sum is equals to what, our root dot well and plus current well. If this is the case, then we will mark our has sum as true. Now this will become true. Doing it like array way, so that it's referenced. We have the reference of something that's outside this function, inner function. So we'll just assign the true value to it. Okay, and then we return. Otherwise, what we do is we basically call path sum on left and right side. Okay, so that will be calling it on the left. And I know so far we have solved quite a bit of problems to understand what's going on here, and then add the root dot well. Right, I'm adding the root dot well, and if I'm adding root dot well, that means this is going with so far whatever I have collected, as part of the current well. So don't think why we are actually here adding the root value, because so far we haven't added the root value, which is root dot left. Okay, same thing on this side, which is right, and we add the value, and that's it. do we need to return anything? No, this is an empty kind of function. And what do? We just call this function. Here as part of our path sum function, and instead of current value we just pass 0, because so far we don't have any value. And that's why here, let's say if the root was only 5, that was a path in itself, and then we were passing. We haven't added the value, but in the base condition, when we are checking if the left and right both are none, then we have to add the value before checking if it is equal to target sum. So we call it, and then let's just return has target sum 0th index. That. So I think this is pretty clear, and let's run it. And left and right, root dot left. Yeah, if this is none, I mean if root is none, we forgot that, and return is ever the case where this is 0. If this is empty, then it's returning false. So I think we can return false safely, because if target sum is 0 and our root is empty, then we just return false always. I was checking if we could return true. If it's 0 and there is no tree, 0 should be. That's why you check these things with your interviewer. So now it should be all good. Awesome. Let's submit it and move on to the time complexity, which is, oh my god, $. I got $10,000. Time complexity would be that was a prank thing. Okay, just got 10,000. Bigger man. Okay, space complexity. That typical Indian scammer. I got $10,000. Space complexity, also big of n, and let's just call it h. H could be equal to n in first case. Awesome. Let's go back to our AlgoYogi and mark this problem done. Awesome. See you in the next problem. Bye bye. China.